Okay, so it's completing the square. I'll do this one quickly since we've already talked about it. But it's a +4. I couldn't see it because of the little steel bar on my board here. That's my excuse anyways. So if this is +4, I'm going to divide by 2 and square. So -5, I have to balance it out by subtracting 4. And that means x plus 2 squared equals 9 when I move this to the other side. And x plus 2 equals ±3 when I square root them. So I get x plus 2 is equal to 3. So x equals -1. And x plus 2 is -3. So x equals -5. Now we're good?
No.
No?
No,
Yeah.
the first one.
Oh, it should be +1. Yeah, okay, there we go. So that should be a +1. My apologies. Now I think if I was to factor it, we could do the same. So it'd be -1 and x plus 5. And now I'm okay? Okay, so you can see why I don't like to use the completing the square method. Yeah, but basically the reason I'm showing you the completing the square method is this method's more versatile. It works for pretty much anything we can throw at it where an answer actually exists. Now, what we could do to come up with the equation, and that's the way the quadratic equation was found, is you take this generic quadratic equation and you complete the square with it. Now, I won't do that in class here, but basically what I'm saying is what I want you to do is do this same process here on all these letters. So there's 4 letters in there. As long as you're okay with algebra, it's all right. But the end result is that you get these answers. Okay? So if this is the quadratic equation we're using, you fill in A, B, and C to it. Now, factoring is much, much nicer than the quadratic equation because look at all this calculation you have to do. But sometimes you can't factor. Okay, so this is where we would go after we can't factor. So I don't like the quadratic formula particularly because it is very messy. So when we try these questions, we're still going to see, can we factor first? That's our preference if it's possible. Okay, but the quadratic formula will work anytime there is a solution. So let's just start by making sure we can pick out the values that go into the equation for A, B, and C. So for the first ones here, A equals 4, B equals 3, and C equals -6. Okay, so it's just picking off the number attached to x squared for A, the number that's attached to x for B, and the constant for C. So if we look at the next one, it's pretty straightforward. A is the number attached to x squared, B is the number attached to x, and C is the constant. Okay, but it can be misleading because I'll tell you that when I look on students' work, this is one of the most common mistakes that I see. And the reason it's so subtle is that where I'm doing the same thing, but first what I have to do is this equation should look like this before I take my values for the quadratic equation. So that means it shouldn't be -6, it's actually +6, and it shouldn't be 4, it should be -4. Okay, so even though it's a small adjustment, it's not going to give you the correct answer unless you can come up with it properly. Okay, so see if you can find the values for A, B, and C in these next 3. Okay, so the only real thing that we have to do is make sure that the terms are collected properly. So there's all my x squareds are collected there. If I take all my x's to the other side, they are all now collected, and I now have an equation that actually will give me the proper values for A, B, and C. And C equals to 7. So in the last one, it is possible that you have a 0, so I get a -5, but nothing is there for C, so it does get included in the formula, it just kind of goes in as a 0. And same thing here, this would be A equals 1, and B equals 0, C is -15. Okay, so that's the first step, is that we can pick out the values. Now we'll actually try solving these quadratic equations. Okay, so first of all, to practice them, the formula is kind of messy, so you want to get used to writing it in your margin. So what I suggest is that you, before you're about to do it, that you write it down in your margin so you can refer to it. If you get in that habit of writing it down several times, then you'll have the formula committed to memory pretty quickly. It is probably the worst formula that you'll have to know in Math 11. It's probably one of the only ones that you're going to have to force into memory like that. Okay, so if we substitute for the first one, so negative b means it's 5 plus or minus the square root, and b squared is 25 minus 4a and c, which is negative 36. All divided by 2 times a. So I've filled in the values here. Now I need a calculator to work out what this is going to be. So 36 times 4 plus 25. This will be 5 plus or minus root 169 divided by 2. And that should be 5 plus or minus 13 divided by 2. And this may be the first time you've had to work with plus and minus on the same equation. So when you have something like plus and minus, it just means there's 2 cases. One here where you go 5 plus 13 over 2, and another one where you go 5 minus 13 over 2. So that's 18 over 2, which is 9. 5 minus 13 is going to be negative 8. So negative 8 divided by 2 is negative 4. Okay, so those are the 2 roots. This one would factor nicely, but we're just getting the hang of using the quadratic formula. So see if you can fill in the formula properly for the next 3 examples here. Okay, some of you may just be finishing up still, but I'll catch up to you. So this is going to be 3 plus or minus square root of 9 minus 4 times a times c, all divided by 2a. So that's going to be 3 plus or minus, so 9 minus 8 will be root 1 over 4. So 3 plus or minus 1 over 4. That's going to give me 4 out of 4, which is 1, and 2 out of 4, which is a half. So there's 2 answers there at 1 or 1/2. For the second example, negative b will be 10 plus or minus the square root. B squared is 100 minus 4ac all over 2 times a. So in this example, I'll have 10. So that's, let's see here, 24 times 4, 96. So it'll be root 4 over 12. So that'll be 10 plus or minus 2 over 12. That'll be, see, 12 out of 12 is 1. And if I subtract it, 8 out of 12, that's going to be, let's see here, 2/3. Okay, and then in the last example,